Okay, my name is Anastasia, this is my colleague Alena, and today we are going to present our work, Why do developers get password storage wrong, a qualitative usability study, and we would like to thank our co-authors from the University of Bonn for their contribution. So in the past, we have seen a lot of important work on how to get passwords more secure, but rather this is work for the end users. How can end users make their password secure? So there are bars, segmented bars, check marks, gradient bars, color changing bars, and this is work in order to get the end users making their password secure. But they are responsible for making their own password secure. But let's think in another direction. Who's responsible for making sure that all user passwords are secured? So if you look at this headline, Yahoo says that all 3 billion user accounts were impacted by the 2013 security breach. There is a big issue here because we know that Yahoo did not store the users' passwords of these 3 billion user accounts in a sufficient manner. The developers of Yahoo, they used MD5. This is a weak and compromised hash function. And within seconds, the plaintext passwords can be retrieved from the hash. And there have been a lot of other examples for password data bank leaks, for example, LinkedIn, Dropbox, and also good old MySpace. And the problem here is that a handful of developers is responsible for securing the end user passwords. Okay, so frequent compromises of password databases highlight that the developers are often not storing passwords securely. Even worse, often they are storing them in plain text. So we wondered, do developers write insecure code because they do not think about security, but could if they wanted to, or is the complexity of the task just too great for them? So there have been a lot of studies on passwords, but only from the end user's perspective. And there have been some developer studies on the usability of crypto APIs. And mostly the studies were of quantitative nature. And we are interested in developer studies in the perspective of password storage. And instead of a quantitative analysis, we aimed for a qualitative analysis to get a deeper insight into the development process. And in order to do so, we designed a qualitative study. So we invited our participants to our lab for one whole working day, and we chose Java as a programming language because it is well known and widely used. And first of all, we gave our participants a small implementation task they had to solve, afterwards a survey, and in the end we conducted face-to-face semi-structured interview with each of our participants. And let's come to our task. So our task involved a role-playing scenario, and we told our participants that they are part of a developing team implementing a social networking platform for our university, and their task was to write code for users' registration and users' authentication. So they had a web form, and they needed to store all the users' properties into the database. So surname, first name, and so on. And note the red box. So the password is one of the user's properties which needed to be stored into the database. And here, the participants needed to be cautious because we know that passwords need to be hashed and salted when inserted into the database. And we decided to test 2 web frameworks. Both were Java web frameworks, and we had JSF, which is Java Server Faces, and Spring. JSF offers a manual level of support. That means that there are no built-in functions for hashing available, and the developers need to write the code for password storage completely on their own. Spring, however, offers an opt-in support. That means that there are built-in functions for hashing, but the functions need to be included by the developer. Also, we investigated the topic of priming and non-priming. This is useful because we know that in an experiment, the participants tend to behave in a way they think the experimenter wants them to behave. And therefore, we gave our participant the same task, store the user properties, including the password, into the database. But we told our non-priming participants that the research goal is to study the usability of the web frameworks, JSF or Spring in general. And the primed participants were told that we are specifically interested in the security aspects of password storage. Here you can see the combination of our 4 different scenarios. So JSF combined with priming, which is labeled JP, JSF combined with non-priming, which is labeled JN, Spring with priming JP, and Spring with non-priming SN. And all these scenarios were the groups we had in our study. And before our main study, we conducted 3 iterations of pilot study. So first of all, we had 4 computer science students, and after this iteration, we decided to reduce the task from users' authentication and registration to users' registration only. Afterwards, we also skipped the Think Aloud protocol because it was too stressful for our participants to comment on every little step and issue they had in such a long-lasting study, 8 hours, remember? And afterwards, we conducted the second round of pilot studies. And afterwards, we announced that the study will last approximately 4 to 5 hours, 8 hours at maximum. When we conducted the third round of studies, and our participants reported that they felt demotivated if they couldn't finish after 4 to 5 hours. Therefore, we needed to discard this group of studies for our main study again and declared it as another pilot study and told our main study participants that the study will last 8 hours. Okay, so let's come to our main study. We had 20 participants at total, 3 female, 17 male, and all our participants were students. We had 18 computer science and 2 media informatics students from our university and our partner university of Aachen, and 7 bachelor, 13 master students, and we balanced our groups with respect to the skills of our participants. The mean age was 24 and it ranged from 19 to 27 years. And now let's dive into the interesting part. The password storage code of our participants was evaluated using a security score. And this score was designed using the NIST standard as well as the academic standard for password storage. So we gave 1 point if the end user password is salted, another if it was hashed, another point if a memory hard hashing function was used. This is the academic standard. For example, script is a memory hard function. Also, the derived length of the hash was examined as well as the iteration count. We also looked at the salt value, if it was generated randomly, and the salt length. So in total, our participants were able to score 7 points from our security score for their password storage code. And let's come to our results. So first of all, the NonPrint Group, these were the groups who were not explicitly told to store the password securely, but keep in mind, passwords always need to be hashed and salted. So how many participants had a basic background knowledge of hashing? 9 of 10. So almost every participant could explain hashing and salting. How many participants have actually decided to store the user password securely? And the answer is 0. So even though this is a highly security-related task and our participants knew about hashing and salting, none of our participants from the non-primed group actually decided to store the password securely. What could be reasons for that? So one participant told us, Actually, when I was in the project, I didn't feel much like it was related to security. The problem is, password storage is a security-related task, no matter what they think. And the problem is, we assume that if you need security, you need to ask for it. Also, one participant told us, I would ask my supervisor about it. There's definitely another person that understood this kind of things. The problem is that we know that in the real world, it's not possible that the supervisor knows about each little security-related snippet the developers are writing. Another participant said, it depends on the company. If it had been a security company, I would have thought of something because they would have minded. And the problem is, we know that users are reusing the passwords on different platforms, and one compromised platform is a risk for numerous other platforms. And we also had some misconceptions. For example, one participant said, I assumed the connection will be a secure connection, like an HTTPS connection, so everything should come encrypted. This is a big misconception because what effect does this a security connection or transmission have if the passwords in the database are not stored in a secure manner?
So now we will discuss the results of the primed groups. Participants of the primed groups were explicitly asked to store the user passwords securely. So again, how many participants had an at least basic background knowledge of hashing? Similar to the results of the non-primed groups, 9 of 10 participants. And how many participants have decided to store the user password securely from the primed groups? So here we have 4 of 10 participants who received 6 of 7 possible points for security. However, none of the participants got full score. So this can be explained by the fact that none of the participants used a memory hard hash function, so none of the participants was aware of recent academic security standards, as for example of Ergon 2, the winner of the password hashing competition. So from the JSF group, 1 participant used the correct example implementation from the web and received 6 points. From the Spring group, 3 participants, SP1, SP3 and SP4, used the Spring Securities built-in library, and so they were able to receive 6 of 7 possible points for security, and all of them chose bcrypt as hash function. So SP1 reasoned this choice by the fact that a lot of forums say that bcrypt is very secure and very up-to-date and has a high vote in some cryptography website. I find it trustable, the Stack Overflow and cryptography forums. We have also evaluated the participants' choices of parameters for secure password storage, for example, the iteration count. So JP2 and JP4 used the key stretching function, and while JP4 decided to use 20,000 iterations, which is NIST standard conform, JP2 copied his code from a blog post from 2013, and so he adopted outdated parameters as, for example, 1,000 iteration. From the Spring group, 3 participants again used automatically default values of Spring by using the built-in library, and so all of them received almost full score for security. We have also evaluated the salts, if participants decided to add a salt. So from the JSF group, 2 participants decided to add a salt, and from the Spring group, 3 participants again, SP1, SP3 and SP4, used a salt, but the salt was automatically generated for them because they were using the built-in library of Spring. So they received a full score for the solution. In the interviews, we have asked our participants to explain hashing and salting, so we were able to assess their background knowledge of password storage security. And an interesting result was that JP1, JP5 and SP5 received 0 points from the primed groups, and however, all of them showed a basic understanding of hashing. So JP1 reasoned this by the fact that he is lazy, So the security task was an extra effort for him, and he perceived security as an overhead. Another interesting result is that JP3 SP2 showed a deeper understanding of hashing. They received only 1 or 2 points out of 7 possible points for security, but still believe they have stored the user password securely. So quite interesting. And SP2 mentioned MD5 with complicated salt is pretty secure. So this is the reason why they had only a few points. Also an interesting result, SP3 received 6 of 7 possible points without having a basic understanding of hashing or salting at all. So he simply used a built-in library and received 6 of 7 possible points for security. We have also asked our participants how they experienced framework support. So from the JSF group, none of the participants felt that JSF supported them. Most even felt prevented from storing the password securely. And JP4 mentioned, I thought of finding something within the JSF framework which easily gives a hash function, but I couldn't get anything. From the Spring group, SP1, SP3 and SP4 all agreed that Spring supported them because it has the built-in library bcrypt for the password. So our key results from our study are the following. Security knowledge does not guarantee secure software and vice versa. So a number of our participants did not feel responsible for security when it was not explicitly mentioned, even in a task so obviously security related like user credentials storage. So it's quite interesting. Another interesting statement, if the employer did not really constrain the programmer with certain requirements, then the programmer will do the work, let's say not in a sufficient way. So the takeaways of our study are the following. First of all, more usable APIs are not enough. So a lot of our participants perceived Spring as more usable than JSF. However, all of them, or a lot of them, did not store the user password securely because they did not know about the built-in library of Spring, and so they simply did not use it. Priming is essential to produce secure applications, so our participants considered secure password storage only if we asked for it. So if you want security, ask for it. And also another interesting takeaway was that our participants reported they first concentrated on the functionality of the application before thinking about security or working on security. So similar to end users, developers consider security only as a secondary task. And we have also takeaways for developer studies. So because of the length and the complexity of our study, the Think Aloud method did not provide us with valuable results. However, the 8-hour study was quite necessary for us. So because small focus tasks will not reveal all problems we have found, and task framing should be reconsidered for developer studies with regard to a mixture of security and functionality development. And another interesting takeaway is that qualitative research reveals essential insights. For example, a lot of our participants with a deeper understanding of hashing and salting did not store the user password securely, and by contrast, one participant was able to store the user password securely without having background knowledge at all. So with quantitative research only, we would have missed out these results. So qualitative research is quite important. We have also to mention that these are only preliminary results which have to be investigated in further studies. And finally, we have a call to action for academics. Find better ways to disseminate the latest security results into standards and tutorials, and also integrate them with popular frameworks because developers are using them. They are using tutorials and popular frameworks, default values of them, and also recommendations of frameworks and tutorials. So last but not least, conduct more developer studies because tons of user data are depending on only a handful of developers, as we have seen at the beginning of our talk with the Yahoo data leak. So thank you very much.
Hello, I'm called Sonia. So if you go back to Bonn, I now hope that you are going to be a site, which is next building to you, and to ask them to go to Stack Chains and update all the questions on password storage. Because if evidence shows that users developers are on static checks, and this is the best way to actually tell them, right?
Could be, yeah.
Yes.
Stack Overflow is used, so we need to tackle it in a way, but I don't know if the questions will be updated that easily. Let's see. But thank you.
Hi, Jeremiah Blocky, Purdue University. So one of the more interesting aspects of the study to me was that none of the developers actually used a memory hard function, and we of course know that memory hard functions can be orders of magnitude more difficult to brute force for an attacker. So I'm curious, do you have any suggestions? What can we do as a community to promote awareness or use of stronger password hashing algorithms?
So first of all, Spring has a memory hard hashing function, so the participants could use one, so script for example, but they did not use it. For example, the tutorials they have used all recommended bcrypt, and the examples were also with bcrypt. So this is maybe the reason why they did not choose script for, or Ergon 2 is not implemented yet, but yes, this could be a solution, just
Update
the tutorials and recommendations also, and the framework Spring recommends to use bcrypt as well. So the Spring framework developers should recommend script and not bcrypt. So maybe this would change the results.
So you're suggesting, maybe the developers of Spring or other libraries need to update their examples?
Their recommendations and examples as well. Yeah.
Okay, thanks.
Thank you.
Hi, Antonio Bianchi from UC Santa Barbara.
Hi.
So I was wondering, so what's your suggestion to perform this kind of user study? Because on one hand, you don't want to influence developers in this case by saying them you should be careful about security. But on the other hand, if you don't mention security, why should they care? I mean, that's not code that is going to be used. So I, as the participant, say, okay, maybe they're asking me to implement something that works, but this system will not be deployed, so why should I care about security? So we had this problem when we did a similar user study, so I was wondering if you have some idea about this.
So we try to tackle it with a role-playing scenario, that's right. So you also need field studies, I think. It's quite it's quite difficult.
Maybe give some tasks to freelancers and then look at the results. It's quite a difficult task.
So a role-playing scenario could help, but you have to mention maybe that it will be used after it. So maybe it will help.
Yeah.
Okay, thank you.
This would be a suggestion.
Thank you very much.
Question. So we always talk about awareness, security awareness, but maybe we're asking too much from the developers, right? One of your findings was the person who didn't know anything about hashing actually got it right because they used the right hash function from the library. What are your thoughts in just supporting these functionalities in a seamless way and not asking for awareness from developers to be aware of the recent literature?
You're perfectly right. This is what we want to tackle actually in our future work, just giving such software to
And
developers.
also, this is the reason why we choose the two frameworks to compare, because Spring offers opt-in, so we had a better support for hashing, as you have seen, and but it
we
could
need
be
opt-out
more,
solutions.
right? Yeah.
Yes, we need opt-out solutions. Exactly.
Other questions? We have time for questions? All right.
Thank
Our
you.
speakers again.